email it to us in class yesterday?
I did not. I posted it in class.
Okay, in geometry, you probably may remember from geometry there's an area formula for a triangle. It is 1/2 base times height, or 1/2 AB. That is true if you have a right triangle. Now, there are several other versions of this formula that are specific to if you do not have a right triangle, in other words, an oblique triangle from yesterday. These ones require you to know 3 pieces of information, 2 of the sides and an angle. So, let's take a look at these formulas and work with an example. Like I said, there are 3 different versions of these, but you'll notice very quickly that all 3 of these work really well together. So, as a reminder from yesterday, we have the following picture. We have 3 sides listed as A, B, and C, and 3 angles listed as alpha, beta, and gamma. Now, the 3 variations of the formula are very, very, very similar. The main difference between them is which 3 pieces they need. But they all follow a pretty similar theme, so let's look at them. The 3 versions. The area of a triangle is equal to 1/2 A times B times sine of gamma. This is one version of the formula. You'll notice which 3 pieces they gave. They gave 2 sides and an angle, and the angle is the one between the 2 sides. So one more time. This version of the formula is 1/2 AB sine of gamma, where gamma, remember, is the angle between A and B. The other 2 versions are very similar. They will contain 3 different pieces, but they will always follow that trend. You'll be needing 2 of the sides, and you'll always want the angle that is between those 2 sides. In this case, you might notice that they end up using all 3 parts in terms of the pairs. You either use A, B, C, but you always use one of the angles in between them. So, the other versions?
In our notes.
Yes. That's probably why I assumed that the word's notes.
No, like is it in our cheat sheet?
No, it's not. Might be a good one to add.
Is this still 10.1?
Yep, still 10-1. So, you also have 1/2 BC sine of alpha. Very similar. And of course, 1/2 AC sine of beta. All 3 of these formulas, very similar. You just need 2 of the sides and the angle that exists between them. If you're given that information, then finding the area is very simple. If you're not given that information, you may have to do a law of sine problem first before you can find the angle. Let's work through 2 examples. One where I'm given these 3 pieces. It'll go by very quickly. One where I'm not, in which case I may have to use a law of sine problem to find the missing piece. So, to do that, I'm going to work through 2 of the even problems from the homework. Let's look at, I want to find, let's see. This is number 44. So this is the easy version when they just give me the 2 pieces. The picture for 44 looks as follows. We've got 16, 10, and 30 degrees. And it says, find the area. Well, in this case, I have 2 sides given to me, 16 and 10. I have the angle between them, 30 degrees. So to find the area, I just plug those 3 things into my formula, and the answer just kind of pops out. Here we go. Again, I'm looking for this specific combination. I need 2 sides and the angle that is between those 2 sides to make this work. All 3 of those versions on the board have those 3 pieces. 2 of the sides, which 2 sides? Yes, 2 of the sides. And whatever angle exists between those. 16, 10, and 30 degrees. So, to find my area, so the area of this triangle is equal to 1/2 times my 2 sides, so in this case that would be 16 and 10, and then sine of the angle that is between them, so in this case 30 degrees. Now this is one that can actually be done without a calculator because 30 is on the unit circle, but most of this homework is calculator problems, so let's go ahead and grab that calculator out. Equals, let's see,
So before I get that solution, and some of you guys already typed it in for me, perfect. I'll ask for that in a second. Note the three pieces I need. I need both sides, and specifically the angle that is between those two sides. If I am missing that angle between, as I will be on the next problem, I may have to do some work before I can take this step. Here we go. So one version the homework or the calculator might give you is the radical version. In this case, the radical version would be, oh no, there isn't a radical version. Sine of 30 is 1/2. So 40? Yeah.
No.
No?
Yeah.
Yeah. Oh, nice and easy. Look at that.
Cool beans.
Cool beans. Don't you dare. So, if I'm given the pieces that I need, this formula is very, very simple. So let's look at one where I'm not given all the pieces I need, where I'm either have the wrong pair of sides or the wrong angle. If that is the case, you may do a law of sine problem first from yesterday to find one of those missing pieces, and then work backwards to find the solution. Here we go. Let's look at a problem like...
Wait, so this is just finding the area?
What about a problem like 48? Here we go. 48 has this picture. It's very similar. It is a triangle. It is an oblique triangle. I have 40 degrees down here in this bottom left-hand corner. I have a 25 right here, and an 18 right there. And I'm asked to find the area. Now, the formulas require that I have three pieces of information. Two of the sides, and the angle that is between those two sides. This term you might see in your text is called the included angle. It is included between the two. Which means for this problem, if I want to use 25 and 18, I need to know this number. If I want to use the 40, I'd have to have that missing side be known. So there's multiple ways to do this problem. That's an important thing.
This problem says find the area or
Find the area.
side?
I need to find the area. But
So if we do like on the other side.
Pythagorean theorem only really works if it's a right triangle. It's not a right triangle, it's an oblique triangle.
So you use the law of sine.
We're going to probably use the law of sine at some point on this one. So, let's take a look at what is missing. I want to find that missing angle. Like I said, the formula is very simple, plug and chug, as long as I have the correct three pieces. If I don't have those correct three pieces, I may need to make some modifications first. Now, do it.
Did you just say like plug and chug?
Yes.
Okay.
The formula is very plug and chug. Ever heard that phrase before?
Oh.
What? I hear it like all the time.
Thank you.
You say it.
I say it a lot. Shows how much Madeline pays attention. All right. Now, to find my missing side or my missing angle. Law of sine is the way we go. I use law of sine to find either the missing side or the missing angle. Either one of these will do. Keep in mind, for some of your homework problems, they'll be very straightforward. You'll be able to plug and chug from the very beginning. Others, not so much. This is one of them where we can't. So, let's set up a law of sine. I want to find that missing angle. To do so, I'm going to use the law of sine. Ironically, though, there's an issue. If I try to use the law of sine right now, I can't find that angle directly. Because here's what the law of sine would look like for this picture. Let me go ahead and label all my missing pieces. So I'm going to call this thing alpha up here. I'm going to call this A. I'm going to call this beta down here, and that's going to be my gamma. So I'm missing three pieces of information. I only really care about one of them, but I'm missing three of them. If I want to use the law of sine, I got to know which ones are which and where they go. So let's look at what the law of sine would say. I have the following information. I have sine of alpha over A, and already I see two variables. That means I cannot solve that one directly.
What if I like labeled mine different? Like what if I put alpha as 40?
That's fine. You will have a slightly different looking one as we go, but the fraction should all have the same material in it. One might have alpha instead of beta, but it will still have the same two pieces that relate to each other in the picture. Okay, so then I would also have sine of beta over 25. And I'd have sine of 40 over 18. Now, if I'm looking at this thing, I could solve for beta, but actually alpha is not solvable right now. The way it is drawn right now, alpha is not solvable directly because there are two variables in that fraction. Don't believe me? Test it out. Pick this first fraction and the last one. The last one's the best one because it contains both pieces. And when I cross multiply, I will have a variable on both sides, and they are different variables. Not good news.
Solve for the other angle, and 180 minus the 280.
That's what we got to do. We're going to solve for the other angle, beta in this case. Using that beta, I can then find alpha using the triangle angle sum theorem from yesterday. This is a roundabout way of approaching it, but it's common in this kind of problem because you have to use what I'm given to do it. So let's go ahead and do that. So he says, hey, we're going to try to solve for beta first. Because if we can find beta, we can actually determine both. Now, what's going to happen here when we go to find beta is, A, I'm going to use an inverse for the first time in this section. So we'll practice that concept again from chapter 7. But there's also a secondary part where if you look at the picture at the end, you'll realize there's something wrong with the answer, and that's why we have part 2 of today. Here we go. As I approach number 48, Garrett says, hey, let's go ahead and set this up and solve for beta. So let's pull that piece out and use the law of sine and try to solve for it. I end up with this. Sine of beta over 25 equals sine of 40 over 18. I cross multiply, one of the properties we talked about yesterday. When I cross multiply, I end up with the following. 18 sine beta equals 25 sine of 40. I divide by 18, trying to get my variable by itself, and I end up with the following. Sine of beta is equal to 25 sine of 40 over 18. I don't want sine of beta, I want just beta. So I will use an inverse to find my solution. Let's see what that means. So I use an inverse. That means that I will get beta by itself. But on the other side, we will, instead of doing sine, we will do sine inverse of this big fraction. 25 sine of 40 over 18. This is one of the properties we talked about yesterday as a prerequisite. You have to remember how to do an inverse in order to find a missing angle like this. So beta should be equal to the inverse sine of that nasty fraction, 25 sine of 40 over 18. Plug it in, see what happens. What do we get? We're in another room down there. Sorry, that's probably hard to see over there. What'd you get? 63.2? Remember how I said that there was a harder version of this problem? It happens right here. Because if you look at the original picture, in geometry we like to say things are not drawn to scale. That's usually a lie, teachers say. They're usually drawn to scale, unless somebody's really stupid or they think you are. Usually they're drawn to scale. So if you would be so kind, take a second and look back at the original picture. It was drawn to scale. Look at the angle we found and say it's beta. We say it's 63.2, and we have the math to back it up. We did not make any mistakes. We have the math to back it up. What's wrong?
No, what was that? Beta equals 100. And then that means that angle would be 80 degrees. That just sounds like 80 degrees.
You have the right idea, but the wrong execution. I like where you're going with that. Okay, if you look at the original picture, beta should be obtuse. It's not. We got 63.2. This number is incorrect according to the picture
That does not mean it's not useful. Now, the law of sine works really well when you are given two angles and one side. When you are given two sides and one angle, there's usually a problem. It's that it's possible this happens. It is possible there's actually more than one solution. 63.2 is actually a solution for a different problem. At the end, I will show you what that problem looks like. It's very similar. It contains the same three pieces of information. The difference is you have to make a modification. So let's talk about what we refer to in this section as the SSA issue. Why do we call it the SSA? Well, because it involves two sides and an angle in that order. And if I put the letters in a different order, how do you get it? The SSA issue. It is possible you get more than one solution. So how do you find the other solution? Well, let's note this. What the picture looks like. This picture has a couple different versions. So here's my angle, here's my side, here's my side. If I have a side, and an angle, where the angle is not between them, it is possible there is a second solution, and that solution may be the right one. It's possible the original one was the right one. It depends on the picture. You have to be investigators for these ones. You have to look at your picture and say, is this number reasonable? 63.2 is not reasonable in this problem. There's a very simple modification to make to find the other solution. So, there are two possible solutions.
Like always.
Yes. The first one can be found directly. It will almost always be acute. The second one is found by taking 180 minus that angle. Solution number one is found by law of sine. Let's call that number x. Okay, I don't want to use alpha, beta, or gamma because I don't know which one it is. So let's call it generic x. How do we find the other solution? The other solution is simply 180 minus x. That is the other possible solution. And if you look at your picture, this makes actually a fair bit of sense, because what we actually found was not beta. We actually found this number on the outside. That's the number we found. The law of sine has this weird consequence that if it's set up the wrong way, in this case a side-side angle is the most common issue, you will sometimes find the outer angle instead of the inner angle. And from geometry, to convert between the two, 180 minus the number. So, if you find that your number does not match, or if it says, hey, check for multiple solutions, it means do this process. It means verify a second solution by subtracting from 180. Now, this means this 63.2 is not beta. My actual beta is 180 minus 63.2, which is 116.8. That is the correct solution. So the law of sine, when specifically dealing with the SSAs, you have to look at your problem and see, because remember, the angle side, the two angles in the side, those ones worked every time. When you have an SSA situation, there's a possibility that you have to be finding a second version instead. And again, it's a possibility. You'll notice that some problems might say, hey, there might be more than one solution. That should be your key indicator light going off, saying, hey, look for the second chance. You only do this for the SSAs. Do not do it for the other ones. This is only for SSA. There will be somebody tomorrow that comes in and says, Douglas, I got an extra solution. They didn't get that solution. I'll be like, it was not SSA. It was something else. Only for SSA. All right. Let's go back to the problem.
So now we know the angles inside are 40. My beta is 116.8. My goal was to find alpha. So here, can you find the alpha for me?
23.2.
So my alpha in this case becomes 23.2 degrees. Now I have the three pieces I need to plug into the formula and find my solution. A common application of trig is you use one trig property to assist you with another trig formula. This is an example of that, where I use the law of sine to find that missing angle, and then I can plug everything in. My solution for the area. The area of this triangle is equal to 1/2 my two sides, 25 and 18, times sine of the included angle, which in this case is 23.2 degrees. 88.6 is my answer. So, notice how I had to use a law of sine to figure out a missing piece so I could use the easy formula. I had to use a different setup, a different process just to find the piece I needed so I could plug in that nice simple formula. This is a couple of the problems in homework have this trick to them. They have this balance where, hey, I got to do this area problem, but to do so I need these specific pieces. I don't have them. Lucky for us, we got the law of sine.
It's like so much fun. Like, whenever I look at the screen, I'm like, that looks hard. And then, like, you're talking about it.
It's a very specific process. And that process goes through every single time. Now, let's look at some more of these with this special tweak to them where I have to find that second possible value. There are a couple examples in your text. I leave those examples to you. They're actually, I believe, on the 4th and 5th page of the homework that I posted. If you need extra examples showing through how the multiple solutions can appear, I suggest looking through that section. Let's do a couple of the ones that may have more than one solution in the homework. Let's see. Let's go to 24.
Is the homework odd though?
Yeah, always, from now on.
Not always.
From now on. All right, look at number 24. What I want to do with number 24 is point out kind of the way some of these questions might be worded, so you can see and note how to look at them. Let's look at 24. Here we go. 24. Now again, this technique we talk about today, different than yesterday's technique. This technique is only useful for side-side angle specifically. If you do not have side-side angle, do not use this. Okay? Look at 24. 24 gives us the following piece of information. Find angle A. This is not an area problem, it's just saying find angle A. This is clearly a law of sine problem because we're trying to find something that is missing. Assuming the following. When little a, which is a side, is equal to 24. Little b, which is a side, is equal to 5. And beta, or capital B, is equal to 22 degrees. Notice they have not given me the picture because they don't want the picture to mislead you. And the problem specifically says on 24, if you read your instruction, it says, use the law of sine to solve, if possible, the missing side or angle for each triangle, or triangles in the ambiguous case. The ambiguous case is the second solution. It's the second solution. So it's saying right up to your face, it's possible this doesn't work. It's possible there's more than one solution. One more time. It's possible it doesn't work. It's possible there's more than one solution.
Is that 22?
Yes, 22.
What are your twos both?
Yeah, exactly. That's what Erica looked at.
These are really close. And it better match the top one.
But look at the 24 on the other side.
All right, you know what then?
You
know what you get now? You know what you get because you complain?
I actually like that better.
Yeah, but then also the other two on the board.
You keep writing your tweets differently. You've done this all year.
I can't write things the same. There, now you get Roman numerals. Take that, kids. Now on, we do all our math in Roman numerals. What you get?
Another 5.
Yeah, the 5 should do.
Beat you all. Now.
Okay, now don't do the actual problem from the new world. I'm really confused.
Yeah, right. I would never do that. Okay, so things to note about some of these problems. You'll note when you look at your homework tonight that some of the problems do not contain the picture. The picture can be misleading. They want you to rely upon the math of the problem rather than relying upon the picture. And it says, specifically in the instructions, it is possible there is an ambiguous case, meaning there's more than one solution. Ambiguous. Not the same. So my first step is going to be I need to draw this picture. Let's look at it. Now, it is possible the triangle will look like this. There is a second possibility, which is kind of neat, which is the ambiguous case, and I'll show that here in a moment. So, let's put my pieces in. I'm looking to find angle A. They called it capital A, so I'm going to draw capital A right here. They tell me little a is 24. Little a should be opposite of big A. That means that 24 should go right here. They tell me little b is 5. So that means the 5 should go right there. And big B beta is 22 degrees. So I have to take the information they gave me and put it into the picture.
24.
24, yes.
I don't like the Roman numerals.
Ha. Don't make fun of my tunes. You can't draw. You can't write. I'm a math person.
Well,
I really don't like how they said angle A and they use beta. Like you're gonna have to use alpha, right?
I may have just looked at it and said beta when it should have been B. I did. Okay.
I was really confused. Like if you're gonna use beta, why didn't they use alpha?
But it's clearly a B the whole time. Alright. So, we're going to find that missing side. The missing angle, A. To do so, we have a clear law of sine problem, so let's set it up. It is possible through this law of sine problem that there is more than one solution. Well, let's talk about what it looks like. Here we go. I set it up. First of all, which pieces go together? Well, angle A and the 24 are going to go together. They are opposites. So when I set up my law of sine, I'm going to do sine of A over 24 equals. The second one will be the 5 and the 22. They are opposites, so they're going to go together. So sine of 22 over 5. This is a good setup. I know it's a good setup because I have a single variable in my fractions. So I'm now going to use cross multiplication and attempt to solve for the missing angle A. I cross multiply. I take sine of A times 5. I take 24 times sine of 22. I end up with the following. 5 sine of A equals 24 sine of 22. I divide both sides by 5, trying to get that sine of A by itself. If I get the trig function by itself, I can then use an inverse. So I'm going to move the 5 first and then use an inverse. I divide both sides by 5. I end up with sine of A is equal to 24 sine of 22. Second. Stupid 2's. All over 5. This is what sine of A is equal to. We talked yesterday about how to get A by itself from this point. We use an inverse. So I invert both sides. That means that capital A will be equal to sine inverse of this fraction, 24 sine of 22 over 5. As we're typing this in, I want to point out something that it says specifically in the instructions. Let's see if you can hear the key words that should be pointed out here. For the following exercises, use the law of sine to solve. If possible. The missing side or angle for each triangle or triangles in the ambiguous case. Round each answer to the nearest tenth. The key phrase there, if possible. What happens when we shove this in?
Inside.
This is not possible.
Why does it say? What's wrong?
If you try to draw this picture the way it is described in the problem, it is impossible to draw it in a way that makes sense. Let me show you to scale what this thing is actually asking you to do. So in this case, do note that for number 24, the answer is no solution. On your calculator, if it says math error or domain error, first check to make sure you typed everything correctly. Assume you made the mistake first. It's a terrible assumption, but if you're self-hating like myself, it's an easy one to make. Then, if you make sure you've made no mistakes, if it says math error, that means there's no solution. There's simply no way this can happen. Let's go back to the original instructions and attempt to draw it to scale, and you'll see that it's not possible to draw this thing. I drew a generic triangle and just threw the information onto it. But if you do draw the generic triangle and draw the information, it's easy to convince yourself, oh yeah, that's totally doable. But if you actually try to draw it to scale, this can never, ever happen. Let's start. Let's see, my three pieces were, I wanted to find A. I was given that little a was 24. Little b was 5. Big B was 22. Double check. I didn't flip those first two.
Yeah, that's about, yeah.
That's right?
Yeah.
Beautiful. Okay. Now, I'm going to try to draw this to scale. I'm actually going to use a little protractor here to make this happen.
You don't need to do this right here. Showing.
No, I'm just showing. Let's go ahead and do it first, please. All right.
Emma Huckabee, please report to the counselor's office. Emma Huckabee, please report to the counselor's office.
All right, let's go right there. Okay. I'm going to start making a 22-degree angle. So my 22-degree angle, I'm going to make over here. Let's see. 22 degrees. Why is this thing upside down? I don't like you. Fine, I'll make it more hard. All right. 22 degrees will put me right about here. Okay. There is my beautiful 22-degree angle. Okay. Now, opposite that 22 should be a 5-foot long segment. So, 5 feet long. Opposite the other angle should be a 22-foot segment. Sorry, say a 24-foot segment. This is the same picture drawn to scale. You might notice that 5-foot piece, never ever going to touch that bottom line. It is simply not the right length. It is not long enough. So this can't possibly happen. This is a no solution. There is no way those 3 pieces can be the case and still draw a triangle. So, it is possible in your homework that you will end up with 2 solutions, that's the ambiguous case, 1 solution, or no solutions. That's why you need to check. Now, each one uses the same law of signs, the same basic format, but checking is the important thing. This is number 24. If I do the problem and do the physical math of the problem, when I draw the problem out and I do the math, I end up with something that shows me no solution through the calculator. That is because there is no solution when you actually physically try to make it. If you took a piece of wood 24 feet long, took another piece of wood 5 foot long, made an angle of 22 degrees, it would never, ever connect. It can't. It's the wrong sizes. These numbers, from the beginning, were bad. But you can't know that until you try it out. You can't know it until you do the math. Alright? Law of sign. It's possible you have 1 solution. This is common whenever we have the angle side. 2 angles given, or the angle side angle. 2 angles given. When you have 2 sides, it is possible you get 1 solution, 2 solutions, no solutions. That is why you check. Questions? All right. We got 15 minutes left. Another game. I'm trying to say 10 minutes. All right. Let's do. Yes, I don't know.
Can you take your stay off?
You want 10 minutes of time off?
Yeah.
Why not?
You don't want to see the example?
No.
I know.
Well, call it a day. 10 minutes left. Tomorrow, I will open the floor. We have covered all the materials for the homework. Tomorrow will be a question day. Monday is when the homework will be due. We will move on Monday. So make sure your homework is finished on the weekends. It is due on Monday. Get it in. As we get towards the end of the year, homework usually becomes an issue because people want to slack off. All right.
Caitlin Reed, Lana Brown, Anna Chaney, you're needed in the office.
Cool. We'll stop there. Tomorrow, I will answer any questions homework you ask me in the time we have. Do note tomorrow during this block is the gold and silver ceremony, so many of you guys will be gone. I will record the questions of the people who stay behind ask. So if you have questions and you will not be here because of the gold and silver ceremony, I suggest you leave them with somebody who will, or message them to me.
Class is still going on even though we're going to the summer.
Everybody's gone.
There's literally 200 kids on the silver card.
There's what?
200 kids out of like
kids.
1,200 kids in the school.
Not very many kids are very.
No, I bet many of you guys are intelligent. Will likely be there. But
Don't you just have to have A's and B's on?
Yeah.
We got like 200 kids out of our 1,200 kids at the
That's
school.
rough if we only have 200 kids.
yeah.
My grade in English continues to go down every day.